Hey guys, today we're going to be talking about equations with variables on both sides. Now you can see a couple examples of that written on the board here. 4x plus 3 equals 9x, and negative 5x plus 7 equals 8x minus 6. So the notable difference between this and other two-step or multi-step equations that we may have seen so far on the channel is we have these variable terms on both sides of the equal sign. What do, right? Like usually we say, okay, well, let's do some inverse operations, get the stuff around the x to go away, and we solve. But how do we get the stuff around x to go away when we have multiple x's? Well, here's the deal. We have a couple of rules we always want to follow. The first rule says get all variables on one side of the equation and all whole numbers on the other side of the equation. That's kind of our goal, really, in equations where we have variables on both sides. We want to choose one side of the equation, left or right, doesn't matter, get all our variables on that side, and then get all of our whole numbers on the opposite side. So for example, with this first problem, since my only whole number is over here on the left, I'm probably going to try to get my variables over here to the right. Now, how do we do that, you ask? We have this second rule. It says to apply inverse operations to move terms to the other side. So inverse operations are the opposite of what's currently happening, right? If we take a look at this first problem, we have 4x plus 3. Now the goal here is actually to move this 4x to the other side, right? Now we know 4 and x are multiplying, right? So usually we'd think inverse operation, that's some division. But we're not trying to get the 4 away from the x, are we? We're trying to move this entire term over to the other side of the equation. So we look at what the entire term is doing right now. And what it's doing is adding to the 3. So the inverse operation for addition is subtraction. So we are going to subtract this entire term to the other side. Now this is what's going to happen no matter what when trying to move variables from one side to the other. If you're trying to move this 4x over, if you're trying to move this 5x or this 8x, whatever it may be, when you are moving entire terms, a coefficient and a variable, you're going to add or subtract it to the other side, depending on if it's adding or subtracting, every time. So I'm going to go ahead and do that. Now, since these are inverse operations, we have a plus 4 and a minus 4. They cancel out. They go away. And I am just left with this 3. Now we get to do our, just kind of combining like terms over here. We have 9x minus 4x. That gets us 5x, right? And at this point, we're down to a one-step equation like we're already pretty comfortable with. We see we want to get the x on its own. We want to get rid of that 5. The 5's multiplying, so we'll divide and cancel these out. And ultimately, we see that x is equal to 3 over 5. And we're done. Let's take a look at the second problem because it's just a little bit more complex. The difference here is we actually have variables and whole numbers on both sides of the equation. So we're going to have to do a lot of moving around to accomplish this first goal. Again, getting all variables on one side, all whole numbers on the other side. We want to first decide what side do we want the variables to be on, what side do we want the whole numbers to be on. Now the thing is here, there's no wrong answer. If you choose variables left, whole numbers right, you're going to get the exact same answer as someone who chooses whole numbers left, variables right. Doesn't matter which you choose. Now I personally, I like to move negative terms. I like to move negative variables. So that's what I'm going to do. I'm going to get my variables on this side of the equation I'm going to get my whole numbers on this side. Again, you could do it opposite, and it's totally okay. So I'm going to move these, go ahead and move these separately here. If I want the whole numbers on this side, I need to move my negative 5x. Now, since it's negative, that means it's subtracting, quote unquote. So I'm going to go ahead and add it to the other side, plus 5x. That will add to my other x term over here, to its like term. And now the equation is going to look like 7, because these will cancel out, equals 8x plus 5x, or 13x, minus 6. So I'm almost there. I'm closer. I no longer have any variables on this side, but this is supposed to be my whole number side. We still have that minus 6 over here. We have this whole number still over here. So I want to go ahead and get that minus 6 moved over here. Since it's subtracting, I'm going to go ahead and add it. Plus 6 plus 6. That will cancel these out, leaving us with just 13x on the right-hand side of the equation. And then 7 plus 6 will give us 13 on the left-hand side of the equation too. I can finish this up just by dividing by my coefficient, dividing by that 13 on both sides. I get x equals 13 over 13, or 1. Simple as that. If you have any questions about problems like this, about moving around equations with variables and whole numbers on both sides, feel free to drop them in the comments below, and I'll help out however I can. Thanks for watching, guys. I'll see you next time.